Questions 1 through 4 on the 2018 Grade 12 Euclid Math Contest. If x is equal to 11, what is the value of x plus 1 plus x plus 2 plus x plus 3? Well, that would be 4x plus 6. X is 11, so that's going to be 4 times 11 plus 6, which is 44 plus 6, and that is equal to 50. If a over 6 plus 6 over 18 is equal to 1, what is the value of a? A over 6 plus 6 over 18 is equal to 1. Get a common denominator by multiplying top and bottom by 3, and you get 3a plus 6 over 18 is equal to 1. Cross multiply, and you get 3a plus 6 is equal to 18. Bring the 6 over, 3a is equal to 12, and therefore divide through by 3 to get a is equal to 4. The total cost of one chocolate bar and 2 identical packs of gum is $4.15. One chocolate bar costs $1 more than one pack of gum. Determine the cost of one chocolate bar. So 1 bar plus 2 packs of gum is equal to $4.15. And they also tell you that 1 bar is equal to the cost of the gum plus $1. So I can substitute that into there. G plus 1 plus 2g is equal to 4.15, and that means 3g would be equal to 3.15, and therefore g would be equal to 1.05. And we want b, so b is g plus 1, so that would be 2.05, the cost of one chocolate bar. A 5-digit integer is made up using each of the digits 1, 3, 5, 7, 9. The integer is greater than 80,000 and less than 92,000. The ones digit is 3, the hundreds and tens digit in that order form a 2-digit integer that is divisible by 5. What is the 5-digit integer? Okay, well, 1, 2, 3, 4, 5 digits. They told me that the units digit is 3. And we are using these numbers here. So 3 has already been used. Then the hundreds and tens digit, so these two guys in that order form a 2-digit integer that is divisible by 5. If it's divisible by 5, then that means this has to be either a 0 or a 5. Well, 0 is not one of the answer choices, so it's got to be a 5. So that means that's gone. Now we have to figure out how to put the 1, the 7, and the 9. Well, the number is between 92,000 and 80,000. So obviously, from the answer choices remaining, this has to be a 9. And then we have a 1 or a 7. Can't put a 7 there because that would be greater than 92,000. So that's the only choice is a 1. And therefore, the only other choice is a 7. So my number is 91753. In the diagram, point D is on AC, so that BD is perpendicular to AC, and also AB is equal to 13. BC is 12 root 2, and BD is 12. What is the length of AC? Well, I got a couple of Pythagorean relationships here. The first one would be to figure out AD. So 12 squared plus AD squared would be equal to 13 squared. And if you do that math, you get AD is equal to 5. So let's put that there, 5. And then the other Pythagorean relationship is 12 squared plus DC squared is equal to 12 root 2 all squared. And if you do that math, you get DC is equal to 12. So they have asked you for AC, which is AD plus DC, and that is 5 plus 12, which is 17. In the diagram, square OABC has side length 6. The line with segment y equals 2x intersects CB at D. Determine the area of the shaded region. Well, this line right here is y is equal to 2x. And the square has side length 6. So that means that this right here, that coordinate is 6. This point on the y-axis. So if y is equal to 2x, when y is 6, what is x? Well, using this equation, x is 3. So that means if we draw this straight down, it will be 3. So at this point right here. Okay, now we can figure out the area of the shaded region. Area of the shaded region, well, the first one is this triangle. 1/2 base times height, the base is 3, the height is 6. And then this rectangle here, length times width, the length is 6 and the height is, or the width is 3, I should say. Okay, so that looks like 3 times 6 is 18 divided by 2, 9, plus 18, and that is 27 for the area of the shaded region. What is the value of the root of 4 plus root 4? Well, 4 plus root 4 is 2. So we have to take the fourth exponent of that. 4 plus 2 is root 6. Well, 4 plus 2 is 6, and then you take the root. So that is the equivalent of root 6 times root 6 times root 6 times root 6. Well, root 6 times root 6 is 6. Root 6 times root 6 is 6. So we get 6 times 6, and therefore that is 36. There is exactly one pair xy of positive integers for which root of 23 minus x is equal to 8 minus y squared. What is this pair xy? Well, I will use a little bit of experimentation just by plugging in values. They're both positive integers, so let's just start with the smallest possible, which is 1, and see what happens. If y is 1, it becomes 23 minus root x is equal to 8 minus 1 squared, which would give me 7, is 23 minus x root. Square both sides, you get 23 minus x is 49, and therefore x would be 23 minus 49, which I believe is minus 26. Well, we do get a solution, but the problem is it's not positive. Both x and y have to be positive. Okay, so that's no good. Let's try the next one, which is 2. If y is 2, we get 23 minus x root is 8 minus 2 squared. So that's 8 minus 4, which is 4. 23 minus x. Square both sides, and I get 23 minus x is equal to 16, and therefore x looks like 23 minus 16, which is 7. And that works. Both of those are positive, and since there's only one pair, that's the only pair we need to worry about. The line with equation y is equal to mx plus 2 intersects the parabola with equation y is equal to ax squared plus 5x minus 2 at the points 1, 5, and q. Determine the value of m, the value of a, and the coordinates of q. Y is equal to mx plus 2, and y is equal to ax squared plus 5x minus 2. Since they intersect, let's set them equal to each other. So mx plus 2 is equal to ax squared plus 5x minus 2. And they intersect at the point 1, 5, so we can substitute that point in. X is 1 at that point. So that will be m plus 2 is equal to a plus 5 minus 2. So that gives me m is equal to 3a plus 1. Okay. So now let's go over to this y equals mx plus b and substitute this point, 1, 5. When y is 5, x is 1. So that means m is 3. So that's the first thing that they wanted us to figure out. So we got that one. Well, m is a plus 1. So 3 is equal to a plus 1. So a is 2. So we got the second one. Now we have to find the coordinates of q. Okay, well, since we have the values of m and a, we can go back and substitute them there and then solve that. So m is 3, so we have 3x plus 2, and a is 2, so 2x squared plus 5x minus 2. And let's put everything on one side, and when we do, we get 2x squared plus 2x minus 4. Divide through by 2, x squared plus x minus 2. And I think this should factor x, 2, 1, plus negative. So that means x is either negative 2 or 1. If x is negative 2, substitute it back into either of these, either this one or this one. And when you do, you get minus 4. And then for 1, you get 5. So our points of intersection are 1, 5, which they called P, and minus 2, minus 4, which is Q. And this is the one they wanted us to figure out. So the coordinates of Q we have also found. The positive integers 34 and 80 have exactly two positive common divisors, namely 1 and 2. How many positive integers, n, with n between 1 and 30 inclusive, have the property that n and 80 have exactly two positive common divisors? All right, well, let's talk about the numbers 34 and 80 first. This is 2 times 17. So let's just list the common divisors first by listing the divisors. 1, 2, 17, and 34. 80 is going to have a few more because that's 2 to the power of 4 times 5. So that's probably going to have 5 times 2, 10. So 1, 2, 5, 4, 5. Let's put them in order. 4, 5, 8, and then 10, 16, 20, 40, and 80. So of these two lists, what's common? The 1 is common and the 2 is common. Nothing else is common. So that's what they mean by exactly two common positive divisors. Okay, so now what we have to do is look at the list from 1 to 30 and which one of those integers from 1 to 30 inclusive have also exactly two positive common divisors with 80. Okay, so let's first list them all. Okay, so let's start talking about this. Well, 1 only has one divisor, so that's not going to be possible to have 2. 2 will have 1 and 2, so that is a contender. The contenders I will leave alone. I'll leave them in the list. 3 is 1 and 3. Well, that's not going to be have anything in common with these. We only want 2 of these to match. 4 is 1 and 2, so that's a contender. 1 and 5, that's fine. 2, 1 and 2. 7 is 1 and 7, so that's not going to be possible because there's no 7 in here. And 1 and 7 are the only ones. This I can extract a 1 and 2. This is 3, so that's not going to be good. 10 is 1, 2, and 5. So that's more than 2 because they want exactly 2. I can't have that, so that's gone. 11 is a prime. That's just 1 and 11. 12, 1 and 2. 13 is a prime. That's no good. 14, 1 and 2. 15, 1 and 5. Those are the factors that are similar. 16, 1 and 2 again. 17 is a prime. No good. 18, I can extract a 1 and 2. 19 is a prime. 20 is going to have 1, 2, and 5, so that's too many. 21, that's going to be 3 and 7. Those both prime, so that's no good. This can have 1 and 2. 23 is a prime. 24 can have 1 and 2. 1 and 5. 1 and 2. 27 has 3s, so that's no good. 28 is 1 and 2. 29 is a prime. And this is, again, a 1, 2, 5 situation. Okay, so our candidates are 2, 4, 6, 8. 2, 4, 5, 6, 8. 12, 14, 15, 16, 18, 22, 24, 25, 26, 29. And I had to cross out that 30. So how many did I underline? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so those 15 are candidates or contenders, whatever. Because all of them you can extract 2 of these 10. But some of them you probably can extract more. And if you can extract more divisors, then it fails what we want. Okay, let's see. The ones that I think can extract more are as follows. 4, for example. That has divisors. I'll just write the divisors here. 1, 2, and 4. So as you can see, it matches 3, so that's no good. So that's pretty much the game we're playing here. The divisors of 8, 1, 2, 4, and 8, and as you can see, that matches 4, so that's no good. Divisors of 12, 1, 2, and 4, again, that's more than 2, so that's no good. And then 16, I think you can extract more, 1, 2, 4, 8, and so on, so that's no good. 24, I think you can extract more than 2, 1, 2, but you can also take out a 4 and 8 and so on, so that's no good. And I think the 28 also, 1, 2, and then 4, so that's no good. So the only ones that are remaining, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those 9 are the only ones that would give you exactly 2 common divisors. So the answer is 9. A function f is defined so that f at 1 is 1. If n is an even positive integer, then f at n is equal to f at n over 2. And if n is an odd positive integer with n greater than 1, then f at n is equal to f at n minus 1 plus 1. For example, f at 34 is f at 17, f at 17 is f at 16 plus 1. Determine the value of f at 50. Well, let's just do a first few. F at 1, that's the one they give you. F at 2, based on the formula, would be f at 2 over 2, which is f at 1, which is just 1. And then f at 3 would be f at 2 plus 1, so that'd be 1 plus 1, which is 2. Okay, so f at 50 is what they want me to figure out. So I'm going to actually go backwards. F at 50 is the same as f at 50 over 2, which is f at 25. F at 25, according to this formula, because 25 is odd, is f at 24 plus 1. F at 24 is the same as f at 24 divided by 2, which is f at 12. And don't forget the plus 1. F at 12 is the same as f at 6, and then f at 6 is the same as f at 3. F at 3 we just got was 2, so we got 2 plus 1, and therefore we have 3 as the answer for the value of f at 50.